Okay, good evening everybody. Recording is on now. So in the last class we talked about the collections framework, and we talked about the interface. I mean, various interfaces and classes that collections, the whole Java collections framework supports or provides. So the top level interface is collection, and underneath that we have two kinds of collections. One is list, the other one is set. List is an ordered collection. Set is not an ordered collection, but set does not take duplicates, but list allows duplicates. Okay. Now we have two different implementations. One is array list here, and we talked about array list the other day. And now there is another implementation called linked list. Okay. And then we'll talk about set later. So let's talk about, we already talked about array list, and array list is backed by array data structure, and array is the fundamental data structure, and array list is a wrapper on top of the array data structure. So it's actually, in a core computer science language, it is called abstract data type, right? Abstract data types, yes. These are called ADTs, or abstract data types. So this is actually a wrapper to the array data structure, but with a lot of behavior, a lot of functionality to it. You know, a lot of things happen when you insert an element in between. It will move all the elements to the right to one more square right, and make the space, and it will insert there. Again, when a deletion happens, the same thing happens. Now, linked list is fundamentally different from array list. So array list is backed by array data structure, and linked list is actually backed by a fundamental data structure called linked list. So there is a fundamental data structure called linked list. In linked list, what happens is that in linked list, each object in linked list is called a node. Okay, each object in a linked list is called a node. And this node has two attributes, two properties, okay? It will hold the value of this particular node, okay? That's called data. It will hold the actual value. Let's say if I'm putting all of you guys into linked list, you know, all of your names. So I'll have Anoop here. Anoop is the actual value in this node, right? And then this is node 1, and then there is one more node here. One more node is antenna, and then there is one more node here, Aruna. In the alphabetical order I'm taking it, Deshikan. Okay, so we have 4 students and 4 different nodes, right? Node 1, this is node 2, and node 3, node 4. So the way these are stored in linked list is, so this is the first node, right? So each node will have 2 different attributes. One is the data. Here the data is Anoop itself, right? The first one is data, and the second one is reference to the next node, whatever it is connected to, reference to the next node, which is a link. Okay, it will have a reference to the next node. So here, let's say in this particular class, let's say there is a class, right? Class called node, right? In the node, we'll have data, which is holding Anoop, antenna, Aruna, Deshikan. And then there is a there is a link to the next node. Okay, this link is nothing but again of the type what? Of the type node. Again the same data structure, same node. So which will again contain the data and link to the next link, next node. Again in this N3 you will have the data and the link to the next node. Again you will have the data, and then the last one will not have any reference to the next node. So the next node link will be null here. Okay, so you will have this link variable will be pointing to this N2. Okay, now N2 again will have data antenna, and then it will have a link to the next node. Again Aruna is N3, and again it will, in addition to the data, it will also have a reference to the next node. Whatever I'll keep track of my data and my neighbor data. That's all. My next neighbor. So for this node, this is the neighbor. For this node, this is the next neighbor, right? For this one, this is the. So this guy does not have any neighbor. So the link to the neighbor will be null here. Okay, so let's say that I want to add a fifth element. Okay, let's say that I want to add a fifth element. So what do I do here? I'll just create a node here randomly. It can be anywhere, right? So who is the next person in class here? Jyoti. So I'll create a node with the data. So I have a node with the data Jyoti, and now I will keep this node. I will change this node's reference now to point to this node. Now N4 will have N5 as the neighbor, right? So, and then who will be the next one for this one? Who will be the link? Link will be null here. Link will be null at this point. Now let's say you want to add an object somewhere in between. I want to say that my list dot add. Okay, I want to add a student in between at the position number 3. Okay, and then I wanted to add somebody. Charan. Okay, I wanted to add. So it starts from 0, 1, 2, 3. Right? So I'm supposed to keep Charan here, but Deshikan is already here. So what do I do in the case of error list? When I insert when I insert an object in between, I'll move all the people to the one step right, right? All these objects I'll move one step right and then make a space and insert this guy here in between. But here, what I have to do is, I will come from 0 to 1 to 3 here, and then what I'll do is, I don't have to do much here. If you look at it, I don't have to do much here. What I'll do is, I'll create a node here, anywhere. And I'll create a node, and then what is the value of the node? Charan. The data is Charan. And now, I will break up the link here. Now this link is gone. This N3 is not pointing to N4. Now I'll make this point to this guy. We'll make the previous link point to this newly created node, and then there is a next node here, right? Our link node, our next, okay? So my neighbor, Charan's neighbor, I'll make it this guy. So I'm just putting in between. So I don't have to change the structure of Deshikan, Jyoti, or maybe 1 million objects on to the right. I don't have to do it. So inserting elements into the middle or even deleting also is pretty simple. Deleting also, let's say I want to delete, let's say, oops, sorry about it. So let's say I want to delete somebody. I want to delete antenna. Let's say I want to delete antenna. Okay. So now what I'll do is I'll get to antenna node. And now what do I have to change here? What do I mean by delete here? In the case of error list, to delete here, once I delete here, I have to move all the right people to one step left side, right? Here I don't have to do anything here. I'll just make Anoop now this N1 point to Arna directly, and then this link is completely gone. That's it. Make sense? So this is how the data structure of a linked list works. So, but fundamentally we have the, so we have list inside, list is an interface. We have two implementations, array list and linked list. So we have two implementations, array list and linked list. Two different ways of achieving the same result. Two different ways of achieving the same result. So in the case of array list, we are using under the hood there is an array data structure. In the case of linked list, under the hood there is a linked list data structure. But every method that is specified here in list interface will work exactly same no matter what implementation you use it. You just say list.add, you add something, it will maintain the order. Okay, that is what list says, right? List says that it is an ordered collection. Okay, it will maintain the order. And then when you iterate through this one also, when you want to retrieve all the elements, in the case of array, you will start here, you will keep going. And the same case with the linked list. You will start from node to the next, because everybody has next, right? So let's say that in the case of array, there are 1 million objects here. I want to find out 1000th element here. In the case of array, it is piece of cake because everything is an index based, right? So I will easily find out, I'll just say array of 9999. That's it, because it starts from 0 and then 1000th element will be 1 at 999 index. It's just the time complexity is O of 1. What do I mean by O of 1? Well, what I mean by that is it takes, irrespective of how many elements you have it, you may be talking about array of 10 size, you may be talking about array of 1 billion size. Fetching an element at a given index is just O of 1. It always takes the same time. It does not depend on the number of elements. Okay? But now, in the case of linked list, it doesn't maintain the index. Like it doesn't maintain the index in case of linked list. So if you ask, hey, can you give me the third element or 1000th element, what it has to do is, it has to start from the first element, 0th, first one, second one, third one, and then it maintains. Oh, now you're asking for the third one, right? I'll give you. So I have to go from, this is like a chain. This is like a small chain. So I have to go from next link to the next link to the next link to the next link to the next link. And then once I figure out that this is the 1000th element in the link, I will return that particular object. But that is not the case with array. Array is directly, I know, out of 1 billion instances, 1 billion objects, because everything is indexed. I know precisely where to go, but here I don't know. I'll always start from the first node and then keep going to the next node, next node, next node, next node. But here, inserting into the middle is piece of cake. All you have to do is just break the existing link, and then you join the new link. You make the new link. That's it. Even removing the somewhere in between is pretty easy. You don't have to move all the elements on the right side or all the elements on the left side. You don't have to do any of that, like in the case of array list. So both have pros and cons. You want to understand your need and then use it. So you are talking about a big data structure that holds like 1 million objects, and you have a lot of requirement to put the elements in between, then go for linked list. You need to read the elements. Your main requirement is to read at some specific location, okay, but not so much of inserting in between, then go for array list. Agree, guys? And I'm telling you all of this. I'm telling you all of this out of my interest. Actually, you look at any of the trainers, you look around, nobody will talk about the underlying the data structures. What exactly is going on? These actually are taught in computer science. There is a specific topic, right? Data structures and algorithm. It's a separate course on this one, but we don't have to talk about it. But some tech companies, like a big companies, if you're going for interviews for companies like Amazon, Apple, Microsoft, Facebook, you know, or somewhat, you know, big tech companies, they expect you to know the underlying structures. I mean, obviously they expect much more than this, but these are the fundamentals. Does it support for multiple link reference? No. There is something called doubly linked list. There is a data structure called doubly linked list. It will actually, it can traverse in both ways, and it will find out, it will always remember both the neighbors. Who is my next neighbor? Who is my previous neighbor? So that you can go in the both the directions. That's called doubly linked list. So this is about the array list and linked list. So without delay, let's go ahead and
Venkat, in what situations we do use this double linked list?
In what situations do we need to use double linked list? I'll talk about that probably later. Once I talk about, I wanted to talk a few minutes about it, but let me, because we just talked about the linked list, right? I want to talk about set, hash set if required. But it's in my agenda to spend a few minutes on that.
Mm-hmm.
Okay, but maybe in the next class, so I'll talk about it. So where are we here? Collections, right? Okay, we talked about array list. So again, I can say linked list. The package is collections. Sure. The difference between array list and linked list, as I told you, that's an implementation specific. So copy this whole thing and then paste it here. Okay, and just change your implementation to linked list. So just change your linked list. Okay, linked list of string names equal to new linked list of strings. That's it. whatever the result that you got it in an array list, you should exactly get the same result, because they both have implemented the list interface, and that is why I say that on the left side you put list. Don't put the implementation directly, and then on the left side you put it. Oh, I didn't tell you how to see here. It is saying sorry, I don't understand. We need to import it. To import it, you can put it here and then control 1, import Java util list. It automatically did. Eclipse did automatically for you. So list of string names equal to new linked list. And now if you happen to change the implementation from linked list to array list, you just change here. That's it. Okay. Your code works exactly same, because there are two different ways of implementing the list interface. But list interface, what it says that it accepts duplicates. It doesn't matter whether it's a linked list or array list, it accepts duplicates and it maintains the order. It doesn't matter whether it's array list or linked list, it maintains the order. That is what the list interface says that. So when they defined that interface, they said that, hey, I will maintain the order and I do accept the duplicates. So whoever implemented it must adhere to that. Whoever implemented it must adhere to that. Okay, so both the linked list and the array list, under the hood their styles are different. Under the hood data structures are different, but they both have to exactly work, whether it is array list or linked list. Make sense? So now tell me one thing. Now tell me one thing. We talked about code to interface or code to super type. Let's say I'm a student printer, okay? I'm printing all the student names. That's all I do here. My class responsibility is to print all the student details, right? So now public void print, okay? And then I will say here that, hey, you give me an array list, okay? And then array list of strings, and then I'll give me students, okay? Now, can one of you tell me what is wrong with this? What is wrong with this code? Or there's nothing wrong. Technically, this is good, but can one of you point me some improvements to this code? Yeah, go ahead, Venkat Krishna. Can you talk a little more?
Can you see?
Sorry.
Can you use iterators to print?
No, my point, yes, you can use, you use obviously iterators to print it, or enhanced for loop, or for each loop. So my point is, what's wrong here? Any of you can point? I mean, can you make any improvement to this one? Okay, let me put the implementation. Okay, I'm printing here, right?
Can we use list instead of array list, maybe in the argument?
Fantastic. Yep. Can you talk why? Okay. See here, this is my implementation. So what's wrong here? So why do you say that rather than using array list, can you take list? Why are you saying that? Can you tell me?
That's basically for code to super type, so that different.
So what do you gain here? Okay, code to super type or code to interface. So what do you gain here?
We can get array lists, or the students could be linked list.
Exactly, precisely. So if I say that array list here, right? Okay. So what I'm saying here is that I'm forcing everybody to send me an array list. So today you send me array list, good. So for some reason on your side, so whoever is the caller, right? So the caller, whoever wants to print student printer, right? Whoever wants to use the student printer, let's say they change the code from array list to linked list, because They're doing a lot of insertions in between. They're using a lot of deletions in between. So they wanted to use linked list. Okay. So once I use the linked list, will you be able to call this print method? Will you be able to call the print method? You cannot. Can you? No, because it doesn't accept it. But if I say that java.util.list, if I just take that just list, not array list, now list is the super type and array list and linked list are the implementations of it. So Java takes always, JVM says that, hey, either you pass me any list if you already have it, or you provide me any of the subtypes. So array list and linked list are the subtypes of the list. So you can pass either array list or linked list. So it's up to you. I don't have to come and change my student printer. Just because my client changed it, I don't have to change it. I'm coding to super type. Always do that. Okay, we talked about it because your same code student printer works polymorphically based on the implementation. Okay, it will call your array list if you pass me an array list. It will call linked list if you pass me a linked list. So your same code works polymorphically. Got it? Did you understand now polymorphism better than before? Why I was advocating for this one? Code to supertype and polymorphism. Agree?
Yeah.
On the same page? Wonderful. So yeah, we'll talk about search and other things, antenna, later. So we'll talk about it. So this is about array list and linked list, and we talked about the differences between them. And now I wanted to talk to a very interesting next collections. Actually, let's talk about set for a second. So we talked about array list and linked list and when to use in what scenarios. So let's talk about set. Okay, what does it say? Set does not accept duplicates, right? List accepts duplicates and set does not accept duplicates. And set, when you're using set, do not assume or do not code for the fact that set maintains the order. Set does not maintain the order. If some specific implementations of set may maintain the order, but in general, set does not guarantee the order. So do not rely on the order. Okay? You pass me ABC, maybe when you ask the set to give you back, maybe I'll give you CBA, maybe I'll give you BSc, maybe I'll give you BCA. So I can give you in any order. So do not rely on the order of the set. Okay? So in set also we have a couple of implementations, and one of the most basic one is called hash set. One of the most basic one is called hash set. There is another implementation called tree set, and there is one more called linked hash set. One more called linked hash set. Linked hash set. There are three implementations at least of the set interface. You have a hash set, you have a tree set, and linked hash set. So hash set is the most quickest implementation of set. Meaning if you want to use a bag that should not take any duplicates, go ahead and use hash set. Okay, there is a reason why you want to use tree set and linked hash set. I'll tell you in a bit, but let's talk about this one. Okay, and some of the very, very, very interesting facts. It's very, very interesting concepts here. So let's talk about hash set demo. Okay. So set is an interface, java.util.set. I'll say string. Okay. Again, student names equal to new hash set. Okay. New hash set. So there is a background noise. Okay. So we have a set of string. Thanks for letting me know though. So set of string names equal to new hash set. So set, you can just go ahead and add. Okay. And then what did they order? Let me order the student names from bottom, their alphabetical order. Yuri. Now, did you observe something? Set does not have an add method that takes the index. Did you realize that? It does not have a method that takes, hey, can you please put this guy in this particular location, in this particular index? You can't say that anymore. If you want to be able to do it, then use list, because set is not an ordered collection. List is an ordered collection. Okay? So Venkat, Krishna, and then Uma. Shaker. Okay. Now let me add Yuri one more time. So what happens here? What happens here? If I print it now, you know, I can print the same. I can use my enhanced for loop even for sets. Okay. I can use okay. So can one of you tell me what happens? What does it print? Just otherwise guess based on what I told you so far. Oh, so Aruna is saying it gives error. Okay, one observation Venkat Krishna said is in random, and Uma and Aruna saying it gives error, no duplicates. Good. So what do you mean by no duplicates? Does it throw an error or Yuri only once? Okay. Or does not print Yuri. Okay. So let's take a look at it. So name equal to, you got Shaker, you got Uma, you got Yuri, you got Venkat. So what did you observe here? One, it did not maintain the order in which you have placed them in the basket. It does not maintain that particular order, because we know that set is not an ordered collection. And number two, it does not add Yuri again because it's a duplication. Okay. So, and in fact, you mouse over this one, add method, it tells you here, adds the specified element to this set if it is not already present. If it is not already present, it will add. Otherwise, it will not add. So this one, when you try to add this one, it doesn't even add because Yuri is already there. So it does not get added. And then it's supposed to be it's supposed to print like Yuri, Venkat, Uma, Shaker, but it actually printed Shaker, Uma, Yuri, Venkat. You can never rely on the set. Okay? You can never rely on the order inside the set. Do not use set if you want to maintain the order. Okay? Use list. Make sense? So two observations, right? One is that no duplicates, and number two, it doesn't maintain the order. That is about set. Okay? I mean, especially hash set. And now, if at all you want to maintain the order, you want to maintain the order for a particular set, then you can use a specific implementation of set. You can use a specific implementation of set called linked hash set. Linked hash set maintains the order. I can actually put it in a separate class. There is a different class called linked hash set that also implements set. The only difference is that it will maintain the order. Yes. So I'm changing the linked java.util.linked hash set. So now look at your observation. Yuri, Venkat, Oma, Sekhar. Whatever the order in which you added, it maintains the same order, but of course no duplicates because set does not accept any duplicate value. Okay, so but can you rely on this one? If you really want to, now let's say in your student printer demo, rather than accepting list, if I accept set, okay? If I accept set here, now you can pass a hash set or you can pass a linked hash set. You can pass either of them and I'll be able to loop through the objects. But in the first scenario, I will get one kind of result, meaning the sequence will be different. That is why when you use set, never code with the reliance that he will always send me linked hash set because he said so. Never code that way. Never assume that set maintains the order. So if you want to be, if your code is absolutely specific and say that, hey, you know what, I don't want duplicates, but I absolutely need to maintain the order also, then in that case, do not expect set in your method. Don't go to interface or don't go to super type. Rather, be very specific and say that linked list. Hey, you know what? You can only send me linked list. You cannot send me a simple hash set which does not maintain the order. Are you getting it? Okay. So now this is how it works. And now, okay. So what do you want to do, Sailaja? Can you speak up for a second? What do you want to do here?
Actually, it does not maintain order, right? In set.
It does not maintain the order.
Not in linked has answered. Yes.
Sorry.
Not in linked has.
What did you say? Sorry. Go ahead again.
Okay. Actually, in set does not maintain the order, right?
You got it.
Okay, fine. At that time, in some cases we don't know the value. We know the index values.
You know the indexed values, huh?
Yeah, I just want to get the particular value. For example, third one, fourth one, or comparing at that time. How can we?
You know that. Okay, now you change from your list to linked hash set, and
then I need to read, right?
Exactly. But see, the point is that linked hash set is also a set implementation which does not accept any duplicates. Okay, that is the first thing. And number two, under the implementation, under the hood, actually it maintains a linked list. To maintain all the values here, under the hood it actually maintains a linked list. That is why it is able to maintain the order. But if you want to retrieve something at a specific location, you can't use set. Okay?
Yeah, okay, fine.
You have to go for list. Because if you have that kind of scenario, then you can't do it. That's my point. Okay, use list for that.
Okay.
Right?
Yes. And one more thing, what is the difference between set and array list and something? I mean, it does not support for the duplicates. I got that point. And
Okay.
why do you go for set?
Why do I
think
go for? See, does it make sense to? I'm a trainer, okay, Java trainer, and then I want to put all of my student names.
Okay.
Student names in a. Does it make sense to? Let's say I'm actually maintaining all the addresses of the students, okay?
Okay.
Okay, and or let's say names of the students, all the names of the students, and then wrote this one, right? Student printer. Okay, you just give me all the names of the students, I'll print it. You tell me, does it make sense to use a list here or set here?
I think set, right?
Why?
There is no need of order, right?
One, no need of order. Forget about the order. My main point is duplicates. Do you?
Yes, it does not support for duplicates.
If I do it like this, right? List guarantee works, but it is possible for the caller to send me a duplicate student twice.
Okay.
Okay? So he can say that list of string students equal to new array list, and then or new linked list, whatever that one is, and then students that add Silaja, students that add Silaja, students that add Silaja. He sent the same Silaja 20 times, and I'll get 20 students here. Okay, I'll get 20 students, but same Silaja here. Does it make sense?
No.
I don't want. So if my requirement is that, hey, don't send me any duplicates, then go for set. Hey, duplicates are okay. Go ahead and, but I want them to be ordered, then go for list. It's very simple. And the most popular interview question, by the way.
Okay.
What are the collections have you used in your projects? Then obviously you should be able to say that, you know what, I've used both list and set interfaces, and I've used both array list and linked list, and I've used hash set, linked hash set. And then the immediate question is, hey, what's the difference between list and set? Well, list is an ordered collection. It maintains the order, and set does not maintain the order. Number two, list does accept duplicates, set does not accept duplicates. Okay, so what implementations of list have you used? Well, I've used both array list and linked list. Okay, why would you use linked list over array list? Well, there is no silver bullet. There is no thing like always use array list, always use linked list. No, depends on the scenario. Okay, list under the hood array list under the hood uses array data structures, and it grows and shrinks magically, dynamically. But every single time it happens, it will copy all of the objects into the new array. And under the hood, linked list is a linked list data structure itself. Okay, if you want to. So I have a specific requirement in my project. In my particular requirement, I will use a lot of inserting in between. So insert this guy at 100th element, insert this guy at 50th element, insert this guy as 25th element. So which data structure should I use it?
Linked list, obviously.
Obviously linked list. Yes.
Yeah.
And I have a huge data structure. I have a huge list. And then I need to be able to find out quickly who is at 100th position. Reading is my main priority.
Yeah, right.
Exactly. So, and then when it comes to set here, hey, which one did you use? Well, I've used hash set. Why would you use hash set? Well, hash set is the most efficient way of using the set. If you just don't want any fanciness, no order, just no order and just no duplicates set implementation, then go for hash set. Hash set is the fastest implementation of set. Okay, any other implementations? Yeah, there is a linked list, linked hash set also. Okay, why would you use linked hash set? Well, if you want to maintain the order in a set, then you will go for linked hash set. Okay? So these are the most popular interview questions. Actually, most out of all the interview questions for Java JTE people, these are the most important interview questions, I would say. So that's about set and linked has set. Now, I wanted to ask a question. No problem, Salida. Now I wanted to ask a question. Earlier we talked about ArrayList demo and ArrayList demo 2. Here, list of animals, right? See here? So in list or set or in any collections API, you not only use strings and integers, doubles, etc. You use the objects too, right? Right? We use the objects too. Now my point is, let's say we're talking about student, right? Let's say, let me create an object called student, right? So tell me the properties of student. Private string name, private, what else do I use? Sorry. Name, city, state, zip, okay? Okay. And then I'll use I have a constructor here. And now I'll have a getters here. I have my fantastic getters. And now let me create a new asset. Asset demo hash set demo 2. Now I wanted a bag. I wanted a big basket. I wanted a big basket. Hey, good point. Yuri, thank you. Student ID. Let's say that I want to have a student ID. Let's say private long ID. Okay, I want this. This is absolutely required for me. Let's say every student in every university or every place will have ID. So this dot ID equal to ID. And then I'll have my getter here. Okay. That's good. Thank you. In fact, how do I know if the two students are same or different? By ID.
With an ID, right?
By ID. Fantastic. We are all on the same page. Very good. From the requirement perspective, we are all on the same page. So if obviously every student will be issued a brand new ID, and then obviously no two students will have the same ID. We know that. That's a basic principle. Thank you for bringing up ID and made my life easy. So now I wanted to have a bag here. Okay? I wanted to say students equal to new. Come on, help me. New has set of students, right? Now I wanted to add 3 students here. Student 1 equal to new student. Okay. Now let's say ID 1, name, since he gave this fantastic idea, Yuri. Where do you live? DC. State is Maryland. Okay. What city is that? Whatever. Okay, 1, 2, 3, 4, 5. Okay. College Park. Okay. Thank you. Student. This is my student 1, right? Now I'm adding second student here. And who do I add from bottom? I'll add Venkat Krishna. And then he's somewhere in Novi, Michigan. 54321. Now let me add third student Uma. Let's say she is in somewhere. Okay, so fantastic. I have 3 students here. Now, how do I add these students to my set?
Using R method.
Exactly. Thank you. So students dot add student 1, students dot add student 2, and then student 3, right? Fantastic. Now to complicate the things, now let's say student printer or something, right? Yeah, let's say student printer, or whatever they do is student printer or student collect the money, whatever. Student printer to make printer. Now we'll say public void print. Okay, and now tell me, what do I take here? Set of student. Now you pass me students in a bag. Did you guys understand this one here? You know, I'm intentionally complicating the things here by introducing one more class. I can do a for loop here and print this guy. But no, I don't want to do it. I want you to understand that there is an object called student printer. There is a method called print here. It is taking set of student. Okay, students is a variable name to hold that set of students. So what I'm expecting here is that, like how you pass me objects, now I'm saying that, hey, give me the basket of students. I will do whatever I need to do it. Agree? Agree, right? No confusion? If you have confusion, then I'll step back and spend a minute here. Now let's say I'll print it. Okay? Student ID. I'll say student dot get ID. Okay? And then I'll just print their name. I'll just print their name, okay? Good. So this is my student printer. And now I'm calling the student printer equal to new student printer. And then I'll say printer dot print, and then, hey, I'm passing you the bag of students here, okay, or set of students here. Can you please print it? Okay. What do we expect? Well, we expect the obvious. 1 Yuri, 2 Venkat, 3 Uma. Okay. And there is no guarantee there is no guarantee on the order, but that's how they happen to be. That's how they happen to be given by hash set. So we got everything. Now, can I make things little interesting now? Do you want to make things little interesting? Let's add Yuri one more time and see what happens. Let's add Yuri one more time and see what happens. I'll say student 4. And then exact ID, exact name, exact city, exact state, exact zip code. And I'll add this guy to the basket again. Okay? What? I'm shocked. Are you shocked too? Set. I just told you that set does not take duplicates, and it's proven here clearly that set does not take duplicates. But why set is taking duplicates? Did we do something wrong, or what's wrong here? I mean, exact same student ID, URI, DC, MD, 1, 2, 3, 4, 5, exact same thing. Why? Maybe the concept is wrong. Set takes duplicates. No, set does not take duplicates, right? We know set does not take duplicates, but why is it taking duplicates here? Anybody?
Maybe the
It's a
reference
different
of the
object. Yeah. That student 4.
Go ahead.
Go ahead.
Aruna, go ahead.
Yeah, it's a student 4, right? It is a different object. It's so that's why it is taken.
Okay.
Maybe the reference are different.
Okay. Okay.
Here you are passing objects as
Go ahead. Those are all good answers, no doubt. All of them are correct answers. I'll tell you. Yeah, you tried your best, okay? So, as you guys said, these are all objects, right? I mean, for that matter, string is also an object. If you strictly talk about it, string is also an object. How did it work with string but not with our own objects? Well, there is a small trick. Your JVM, it blindly gives it to hash set, right? This object will be given to hash set. Hash set behind the scenes, what it does is, it will add student 1 blindly. And then it will add student 2. When student 2 is given, it will check whether it already has a student 2. So it will check with every single object that it is already holding in the basket. Okay? It checked, no, student 2 is different. So it added student 2. Now student 3 came into picture, and then it checked with student 1 and student 2. They are different. Okay, though it's student 3 added. Now, student 4 came into picture. It checked with every object. Student 1, are you same? Student 2, are you same? Student 3, are you same? No. Student 4 is different. That is why it added. So your hash set does not know. Your hash set did not know that these two objects are same. In JVM, under the hood, if you open up, there is something called, JVM holds all of this memory, right? So that is called heap, right? They're all having. So here, 4 different objects, student 1, student 2, student 3, and student 4. And then these have object reference that are pointing to this one. To find out if this object is same as this one in equality, okay? To find out if 2 objects are exactly same, it uses a method called equals. To find out if 2 objects are exactly equal, it calls a method called equals. There is a method called equals in java.lang.object. In java.lang.object. We know that java.lang.object is it's like a even addum to all the objects in the world, right? Java.lang.object is the granddad for all the objects in Java, including the one that you are writing. It is a parent object for every single object. So there is a method called equals. So it will call the equals method. This is student 1, student 2, student 3, and when you try to add student 4 here to the hash set, the basket here, first you will add S1, and then when you try to add S2, what happens is it will check, hey, S1 dot equals S2. It will call under the hood this equals method. And then that equals method, by default, the implementation that you are getting from your granddad, in every single object you have the implementation for this equals method that you are automatically getting. The equals method, if you open up and see, the implementation is that there is a equal to operator under the hood. Okay, what do you mean by equal to operator? So these are two different, student 1, student 2, student 3 and student 4. There are 4 different objects, right? So there is a student 1 object reference, student 2 object reference, student 3 object reference, and student 4 object reference. So student 4 is pointing to this guy here, student 3 is pointing to this guy here, student 2 is pointing to this guy, student 1 is pointing to this one, right? So these object references are nothing but the memory address of these actual objects. It is like a remote, right? The remote is nothing but the memory address of the actual object that is stored in heap. Okay, so these memory addresses or these object reference are never same. These memory addresses are never same for 2 different objects, because the 2 different objects in heap in JVM. In JVM's heap, there are 2 different objects, so obviously they both will have 2 different memory addresses. That is what this guy is storing. So 2 different objects will never ever be same. So if you look at the student 1, if you do it equal to student 2, okay, compare any 2 different objects, you will always get false, because they're actually pointing to 2 different objects that are stored in heap. In your equals method, the default implementation that you are getting from java.lang.object is that the 2 objects are compared like this with equal to, meaning if these 2 references are pointing to the same object, then they are only same. So you have O1 and O2. If these 2 are exactly pointing to the same object, in that case they both are same. Otherwise they are never same. So here we have 4 different objects and they are never same. So you are getting the default implementation from java.lang.object, which says that no 2 objects are never same. That is why these 4 objects are completely different. That is why your hash set allowed you to add them to the basket. Okay, I mean, all of this is okay, all of this is good, but here this is ridiculous, right? This is like a student 1. They both are exactly having the same ID. How can you have 2 different students with the same ID? And if you have 2 different objects with the same ID, then they're same. We're just talking about it, right? If I give you 2 different students and if they have both the same ID, then they're same. Well, you know your requirements, but JVM doesn't know, or your hash set doesn't know. Your hash set, all it knows is blindly calls your equals method. And your student also has the equals method. If you really understand it, there is a equals method. If you really look at it, student dot, there is a equals method. See, look at it. There is a method called equals. This is what by default it calls and compares 2 different objects. Hey, are you guys same? Are you guys same? Are you guys same? Student 1, when you add a student 4, it will check with every single student out there already in the basket. It says that, hey, S4, are you same as S1? Are you same as S2? Are you same as S3? Are you same as, it will compare with every single object. Equals. But by default, what you get is every single object will be different, because it will, by default, it will do the equal to, meaning object reference comparison, not the values inside the objects. You only know that if students if two students having the same ID are same. That is your requirement. Maybe in my case, if two students having the same ID, city, state, zip code are same. Maybe in some other people, two students having social security numbers same, they are equal. So these are all our requirements. How does HashSet know all of this? Well, it wouldn't know. Now let me, I know I told a lot of things here. Now let me step back and rephrase it. What I'm saying is the equality that you are getting from your java.lang.object is wrong or is not sufficient. What do you do? If you're getting a behavior from your parent and you don't like it, what do? Any of you, in my animal, exactly, in my animal, all the animals eat one way, but no, lion eats differently. I don't like my eat method that I inherited from my animal class. So what do? Override. So what do we have to do here? Override the equals method that you inherited from your java.lang.object. Exactly. So let's override. Okay? See here. This is the method signature equals, and then it gives you java.lang.object itself. The reason it gives you java.lang.object is because you can pass any object here, because every object has java.lang.object as the parent object. So you can pass that, hey, you give me either java.lang.object or any of the subtypes, meaning every object in the world, it doesn't matter who created it, can be passed here. Are you guys agree? Agree? So now let us find out. So what is our equality, by the way? What is the definition of our equals? If two students having the same ID are equal is what I wanted to say. Do you guys agree? Or you can do something like this. ID, name, city, state, zip code, everything has to be different. You can definitely do that way too. But I'm saying, I'm going with a more logical. If two students having the same ID, that means they are exactly same. Now, I need to compare the external object that you gave it to me with my object that I am in, which is this, right? If I say this dot ID, I'm talking about this particular instance, right? And now, okay, let's keep that this dot ID aside for a second. Now, you gave me java.lang.object. Okay? Now, you gave me java.lang.object, meaning it can be any object, but can a student and animal be same? If I give you student dot equals an animal, are they same? Can I say student dot equals pug? Should it be same or? So first of all, whatever the object that you passed, it must be a student itself. If it is not student, then we say it is not equal there itself. You guys agree? And there is a concept called typecasting. Okay, what exactly do you mean by typecasting? Well, in Java, you can always pass, in my method signatures, I declare the super types. Okay? So I will say that animal, and you can pass me any of the subtype of the animal, right? You can pass me animal, you can pass me the dog, you can pass me the pug, you can pass me the subclass of the pug, you can pass me the grandchild of the pug. You can pass me any level, right? That's how it works. But if you're looking for a specific object in that hierarchy, okay, you can typecast it. If you know what that object is, you can typecast it, meaning you can reduce that object to the actual type. You can reduce that object to the actual type. That is called typecasting. So I will say like this. If I know that the actual type, as I told you, JVM does not care about the type that you are referencing to. JVM cares about the actual type that you passed at runtime. If my actual type that I passed at runtime is dog, and if I want to get the actual dog object for some reason, you can typecast it, meaning dog D equal to, and here you do it like this. So you take your object, you are reducing or you're cutting down your object from animal to dog here. You are actually, so let's say there is a long, okay? Somebody passed me long, but I want int here. I want my data type to be int here, okay? Now, but I know the actual value inside the long is not, it's not a big number. It can definitely be placed in an int variable. So in that case, I can say int I equal to, and then this is called typecasting, meaning I'm reducing from the larger object to one of the smaller objects or subtype of the objects. And you can actually, there is an operator called, you can check, there is an operator called object, there is an operator called instance of. If obj,
Instance of, right?
what is that? If object is an instance of student, okay, if whatever you passed me, see, this is actually, my compiler thinks that it's a java.lang object, right? But I want my student, I want to convert that into a student because I know the real type at runtime has to be a student. But why did they define with an object? Why not a student? Because they want to define this method for every single object in the world. Every single object is the subclass of java.lang object. That is why they said that, hey, you know what? To make things generic, I'm putting you object. Well, but I can send an animal also because animal extends object too. Animal is a subtype of object too. But well, yes, I know you can send it. But whatever you sent is not an instance of student. Okay. If not an instance of student, actually I can do, if it is not an instance of student, okay, if you are not an instance of, so this is not, by the way. So what I'm doing here is that whatever the type is out there in java.lang in this object at runtime, if it is not a student type, instance of is used to check if at runtime to see if the actual type is of particular class or not, particular object or not. So if it is not a student, then what do I do? Return false. So if I send animal, dog, pug, everything, all of that, I'll return false. Okay. Now, I'm returning here itself. So if I come to this line of code, that means whatever has been passed is a real student. Now, let's typecast this guy to that student that equal to. Okay. Now, I typecasted my object to the actual student type. The reason is I called this as a that. You can call anything. Typically in equals method they call it, because this is in this object, whatever the object that you passed as a parameter, I call it something else. You know, I can call it object or student or whatever you want to call it. Typically they call it that You can call whatever you want to do it. Okay. Now tell me, return this dot id equal to this dot id is long, right? Student dot get id. So you know what I'm doing here? If this dot id, this object id is same as in the object that you provided me, I'm getting the id from there, student dot get id. If they both are exactly same, return true, otherwise return false. By the way, you don't have to do this one in Java. If this dot id equal to get id, then return true. Okay. Else, this is what I typically see people doing it, but this is a redundant. You don't need to do this one. Java can magically just do a return here. It automatically, it will do this code for you. So compare this one with this ID. If two objects are having the same ID, then they are same. So we overrode the equals method based on our requirement. Now, if at all, when you go back to job, and then if your requirement says that, hey, two students having the same social security number and same ID, then they are same. Because probably 10 years back, student ID, maybe they're getting reissued again. So if they both are having the exact same social security number and exact same ID, then they are same. Then you will do it here. You will change that logic here. Make sense? Are we on the same page now? I'm sure it is. It is definitely. It must be going above your head for at least few of you, and that is totally
Venkat,
fine.
I have one question, Venkat.
Absolutely.
I remember you saying that equals will check the value in the hash code table, not the hash code. Hash code is the address, but the contents of the table, it will check.
I'll talk about the hash code later.
Okay.
I'm coming there to hash code, but here, did you follow so far, or?
Yeah, the difference between equals and equal to.
Okay.
That's what I'm confused.
Okay, definitely, no problem. So now, student S1 equal to new student. Okay. Now student S2 equal to new student, right? Now we have two students here, right?
Right.
Now what happens, tell me? Two different objects will be stored in heap, right? This is one object, this is another object, right? Now let's say inside this one student 1 details, and inside this one student 2 details. Now S1 and S2, the actual remotes themselves are actually stored, they're not actually stored in heap, but they're somewhere stored here. Okay, let's say S1 and S2 are stored outside of the heap. Okay, so what I'm saying is this S1 and S2 are the memory addresses of the actual object on the heap. This is the heap, right?
Yeah.
Right. So S1 is the object, S2 is the object. Now this S1, this is the remote to the actual object. Do you agree, Venkat, so far?
Yes.
Now let's say this is a memory address. Let's say X6 Z3 and let's say 1 2 3 4. This actually what S1 is holding is that memory address here. Okay?
Yes. Yes.
Now S1 is pointing to this object though, but It's just holding the memory address of this guy. That's all. S2 is holding the memory address of this one. So that JVM at any point, oh, when I say S2 dot something, right, it will know that, okay, when you say S2, okay, you're talking about the object that is stored at memory address 1, 2, 3, 4. So when you talk about S1 dot get name, then it said that, oh, you're talking about you're talking about an object in heap that is stored at X6Z3. I got it. Are we on the same page so far?
So far, yeah.
Fantastic. Now, when you say S1 equal to S2, what you're doing here is that, hey, are these two exactly pointing to the same object? Meaning, do they have the same
Address.
same memory address? If
Okay.
they happen to have the same memory address, maybe you may be wondering, hey, when would they have the same? Can I do a magic here?
Yeah.
I'll do this one here. What am I doing here? Tell me, what is this statement doing? S1 equal to S2. Now,
It is comparing the two memory addresses.
no. This is not comparing. This is not equality. This is equality operator. This is
Assignment.
exactly
Assigning S2 into it.
assigning. So I'm assigning S2 to S1, meaning, what does it mean?
I'm
So now, S1
both are pointing to the same object.
Exactly. Now S1 is also pointing to S2 now, right?
Yes.
Right? So now this link is gone. Now you tell me S1 is pointing to S2, right?
Yep.
Now in that case, when I call S1 equal to, because they have the same exact memory location, which is 1, 2, 3, 4. Agree?
It's true. Yeah. So it will be true.
Only in that case your equal to will be
True.
true. So
But
now,
equals, I'm saying EQUALS.
let's go to, are we on the same page so far? We are, right?
Yeah. So far, I never had any confusion so far.
Okay, good.
My confusion was that word EQUALS.
Equals method.
Equals method. What that will do is it will go inside and compare the contents of the
Exactly.
memory location.
Let's talk about it.
You said that the set method will implement the EQUALS, right? When it implements that, won't it check inside the memory location? That is my question.
Yep, we are getting there. So now we are all clear on this one, right? So this equal to for any two object references are equal if their object references are exactly pointing to the same object in heap.
Right.
Okay? Now, it's for everybody. Now let's talk about equals method. So what I'm saying is there is a method called equals in java.lang.object. So every object inherits this method. Inside that, what they did is they did like this: return object 1 equal to object 2. That's what they did.
Okay.
This is what they wrote. Who? Java people have provided to you to start with. But this is not what we want. What we want is, okay, and also I was saying that your set implementation, your hash set or linked hash set will call the equals method to see if the two objects are exactly same.
Exactly.
Now, let's go to a basket here. Now, I'm putting a basket. Now, in this basket, I added S1 here, student 1 here, right? Now I have S1, S2, S3, F4. Now, when I add S2, you know what it does? S2 will be compared like this. Hey, S1 dot equals S2. Because I don't know, I need to find out if these two objects are exactly same. If they are exactly same, then I don't want to add. Because my set implementation says that, hey, set is not supposed to accept duplicates.
That's what I was thinking. S1 EQALS S2 means it will compare the contents, not the memory address.
Can you please let me finish? I know.
Okay.
I'll talk for the next couple of minutes. So, because it's for everybody, Venkat also. So in the case of S2 here, now, when I add this S2 to the basket, it will check, hey, are you same as S1? How do I know if these two objects are exactly same? Well, I call the equals method. It is there in java.lang.object. Okay, I'll call this one. And this guy returned false. Why did it return false? Because we have not implemented equals. It does not know that if two students having the same ID are same. Well, nobody said it. Right? By default, when you say object or your student dot equals, it is actually equal to. This is what you are getting from java.lang.object. If you don't like the equals functionality that you are getting from your parent, override it and you specify exactly what you want to say. Now, we somehow overrode. I don't want to go into the code now, but we overrode in such a way that two objects having the ID are equal. Two objects having the same ID are equal. Now also your hash set will exactly take it. Okay, now S2. Okay, now I will call S1 dot equals S2. I will compare with every single method out there in the basket. This is the basket. This is my set already, right? So set is maintaining under the hood basket, so it will compare it. S1 dot equal S2. No, this is false. Why is it false? Because we overrode equals method and they both have these two different IDs. So S2 will go and sit in the basket. Now let's try to add S3 here. Now it will do S1 dot equals S1 dot equals S3. It returns false. Now I'll go check with S2 dot equals for S3. Both of them return false. Why did they both of them return false? Because they have the different student IDs. So S3 will be added to the bucket. Now let's go to S4. S4 have the same ID as S1. Now I will call S1 dot equals. I'm checking with every element in the basket. And the first element happens to be S1. So I'm checking S1 dot equals S4. Hey, are you guys same? Oh, now it will return true because they both have the same student IDs. But how does it know? Well, we overrode and provided the actual functionality of equals. How the equals should work. We provided it. We provided. And our functionality is that, or our implementation of equals is that if the students having the same ID, they are equal. In this case, it becomes true. That is why S4 will never get added to the basket. That is why you will not see S4 now.
So in other than set, if I use that EQA anywhere else, which implementation it will use? Will it use a default?
Everywhere. Forget about hash set. Okay. Everywhere. No. You tell me, Venkat. Once you overrode a method, it always calls your method only. It does not call the default implementation that you are getting it. You don't get that anymore. Are you getting it?
Not in this case. Let's take any other. Not this package.
I'm saying anywhere in the world. I'm saying anywhere.
Without overriding, if I use EQUALS, I will get equal to, or will it compare the contents of
it will never compare the contents because it doesn't know. If you do not override it, this is the default implementation. See, that's what we're talking about, right? The default implementation, what you are getting from our granddad is equal to. This is what is implemented here, right?
I was thinking all the time when you use EQU, it will always compare the contents, not the memory. I was thinking.
No.
Okay, I'm good now.
At least I'm able to clarify that one unless you override it. Simple.
Really? Okay.
Unless, the reason, I will tell you the reason also, Venkat. Okay, the reason is, if JVM goes and looks at it, okay, That's a smart way of thinking, actually. Very good way of thinking. So let's say student has 4 fields: ID, name, city, state, and zip code. If JVM says that, you know what, in equals method, okay, I will compare every single field for both the objects and say if the 2 objects are same or not. Is that a fair statement? In this case, I don't want to compare because my requirement is different. My student object may have 100 pieces of state information, but when it comes to equality, when you say, can you tell me when the 2 students are equal? Well, I'll tell you that you don't have to compare the 100 objects. You just compare one object, which is student ID. How does JVM know about it? Are you with me?
I'm good, Venkat. Yeah, it's clarified.
It's clarified, right? So yeah. The default implementation of equals is equal to, and when you say equal to, this is one of the most popular interview questions, by the way. What is the difference between equal to, and equals method? What is the difference between equal to and equals method? Okay, equal to, when you compare 2 objects with equal to, you are comparing 2 different object references, whether they are holding the same memory address or not. But when you use the equals method, okay, you can override that equals. Just because you are writing equals method, it doesn't magically, nothing happens. Nothing will happen magically. You have to override and tell JVM what exactly your requirement by 2 objects are equal, or 2 students are equal, or 2 laptops are equal, or 2 animals are equal. And your requirement is different from my requirement. Maybe I will define that every cars having 2 different wins are equal for me, but in your, maybe in Europe, situation is different. Agree?
Maybe for a string, if I compare 2 strings and I use EQ, UA, LS,
I will come to string. I will come to string in.
Oh, okay. Now I got it. The string you use equals. I got confused with that.
I will come to string in a minute. But everybody, let me give a minute to everybody, because this is very core concept, and it's not easy to comprehend. I totally understand. It's not an easy topic. You don't get it first time, you don't get it second time, no big deal, but at least for now, does it make sense? Or
Yes. Yep.
Everybody also? Wonderful. I know, to really get these concepts into bloodstream, you have to watch this video a couple of times, but it's the most important. Now I'll tell you. Now, I'll step back here for a second and then talk about I'll come back to the students in a second, and then I'll say, or I'll not confuse you for now. I'll just first execute this one. Now, we provided our own implementation of equals now. Okay, and then we said it, hey, if the 2 objects having the same IDs, they are equal, is what we are saying. And now go to student 1, student 2, student 3, and student 4. When the student 4 is trying to be added into the basket, your hash set says that, hey, I currently have 3 objects in my basket. I will compare with every single one of you. Are you same? All these guys, sorry, we're talking about student 4, right? Okay. The first object itself will return true because they both have the same IDs. Even though they have every single field is exactly same. URI, DC, MD, 1, 2, 3, 4, 5, exactly same. Okay, but it doesn't have to be. I can give my name here. Okay, my city, my this one, then my zip code. Okay, Even though all the fields are same, it doesn't matter. It will only worry about the ID because that is how we defined our equality for our student object. That's my point. Go ahead and let's execute this guy. It still did not work. It still did not work. Did it work? The first one is Yuri, the second one is Venkat, the third one is Uma, and the fourth one is Venkat. I was hoping that hash set is supposed to compare all the objects, and then finds out that we just overrode the equals method here, and then these two guys are exactly having the same IDs. Why is it still taking two objects are exactly same? We defined our own equality, even though it is not working. So things are not.
City is different.
But do we care about the city here? Tell me.
No.
Do we care about the city? If the two objects have the same ID, they're exactly same. These two objects, go ahead. If these
maybe we didn't iterate through it, or and then we compare each object with ID. Yeah, first object with the other.
No, we don't have to do it. Hash set behind the scenes does it.
Can do that. All right.
Okay? I can't expect this answer from any of you because it's a little complicated, but I'll explain why. We provided our own equality, right? But still, this guy is not working. Now, in the case of hash set, the reason here, look at this one, hash set. Okay, what exactly is a hash? We need to understand in the hash set, we need to understand the first four letters, hash. Under the hood, it uses a mechanism called hashing. I'll tell you how exactly this works. Really what's going on in any hash-based functions like a hash set. There is something else called hash map. I'll talk about that one too probably a little later. Let's talk about it. So the implementation here is hash set. Now, let's talk about this hashing. So the data structure I'm saying, we talked about array list. Array list is backed by arrays. Linked list is backed by linked list data structure itself. Now let's talk about hash set. Hash set is based on a data structure called hash table, and the actual mechanism under the hood depends on something called hashing. So what happens here is that, okay, under the hood, it's actually an array. Under the hood, it's actually your hash set. Under the hood, it is actually backed by an array only, okay? But index, right? There is no index. When you give me student 1, when you say set.add student 1, I will not go put this guy in the first position. And now when you give me add S2, I'll not go put it in the S2. That is what your array list does. But my hash set does not do that. What hash set does is, so it is backed by array data structure, but it needs to find out when you give me an object, I need to find out where I need to put it in my array. Where is the index? So here, let's say that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Okay. Let's say this array has the size of 10. Now when you give me an object, okay, I need to put it somewhere here, and I need to be able to retrieve also. For that, what it does is, all the hash based functions, they use something called hash code. So there is a method in java.lang.object class in our parent class. As I told you, java.lang.object has a method called equals, right? Similarly, there is a method called hash code. So hash code returns some random number. Okay? By default, it returns some random number, depends on your object reference, depends on your memory location of the actual object, which is not going to be same for two different objects. So what happens is, it will call that hash code method on every object, and then it will figure out, oh, where should I put it now? Okay, this hash code, let's say this, I got 1, 2, 3, 4 hash code. Okay, now it will do some very complex algorithm. I mean, it will divide it by the size of this array to find out where exactly I need to put it in this array. All I need is the position where I need to put this object in this array. Now let's say this is 1, 2, 3, 4 divided by 10, and then I did some, they do some complicated algorithms behind the scenes, and they'll find out one number below 10. Let's say there is 6. Now I will put this object here in this location. And now when you give me S2 here, okay, now S2 here, I will also call the hash code, and then let's say hash code of this one is 6841, and then again it will perform some complex algorithm, and then it will find out the index here, let's say 3. Now it will put S3 in index 3. Got it? So your hash code method will be called to identify the index where your object needs to be placed by the backed up array. If at all, I also got another hash code here, right? Let's say I added student 3 here. Student 3. Student 3, let's say, happens to have the exact same hash code and exact same 6 number. Now, there is already S1 guy is sitting out there. Now, you gave me S3 with the exact same hash code. What happens? Now, I will go to the 6th position and give and ask, hey, can you give me all the objects that are sitting in the 6th position? It will give me S1. Now I will compare. Now I will call the equals method and see if they are really equal. If they are not equal, I will go ahead and put S3 here. If they are equal, then I will not put it. So S1 and S3 are sitting here. Your S2 is sitting somewhere here. And now you called S4. And S4 happens to have the exact same hash code as S2, and then index is 3, and now it will go here. Hey, can I place S4 here? First of all, I need to find out. Now, I don't need to compare with every single object. Earlier I was saying that hash set will go and compare with every single object. I just oversimplified to make my point across. Now I'm even deep diving into this one. Now, S4, I don't have to compare my S4 with S1 and S3 because they have different hash codes. The deal here is that the standard rule that's followed by JVM is that if two objects O1 and O2, if they have different hash codes, then they are different objects. But if they have a same hash code, they may or may not be same. They don't have to be same. That is why S4 and S2, S1 and S3 has the different hash code and they are at index 6. Now S4, I don't need to compare. There may be million objects in my hash set, but there is only S2 at index 3. I only need to compare with S2 to see if this object is same as S2. I don't need to compare with the other 999,900 other objects. You got the point. I do not need to because I have the different hash code. So when two objects are having the same hash code, they don't have to be same. But if two different objects have the different hash code, then they're absolutely different. So, got it? So what happens under the hood by hash set is that it will call the hash code. Now, let's go to our point here, right? It will call the student one. Student one, let's say they gave, if you really want to find out the hash codes for all of them, you can simply call this student one dot, there is a method called hash code, right? Now, this is the hash code. By default, this will be calculated by your JVM. If you don't do anything about it, it will be calculated by your JVM. Very interesting, very complicated topic. See this one? So all these objects are having different hash codes. So obviously, this guy, based on the complex algorithm, it says that S1 may be sitting here, and then S2 may be sitting here, S3 may be sitting here, and then S4, when it comes to S4 gave a different hash code compared to this guy. If the hash code were exactly same as S1 and S4 had same hash code, then it would have come here and then it would have called the equals method to see if the objects are really equal, but they have a different hash code. So your S4 is sitting somewhere here. Because there is no conflict in the objects at the location where S4 is sitting. Are you getting the point? So your hash set asked this guy, hey, can you give me your hash code? Okay, it gave me 182.916.4700. Using my complex algorithm, you tell me the index. Okay, index is 9. Okay, I'll go put this guy here. If at all there was S1 here, then I would have checked to see if these objects can live together in the 9th location, or they're exactly same. I will call the equals method on every single object in that particular location. But since your hash codes are different for all these objects, I don't have to nicely compare them, because two different objects, S1 and S4, having the different hash codes, meaning they are two different objects, they're actually sitting two different places. I don't have any contention. Happily, they are different objects. That's how my hash set thinks. So what point am I making now with all of this story here? What point am I making here? I'm making a point that you need to override your hash code method and provide according to the rules. What are the rules? Well, the rules are defined like this. If O1 object1 dot equals O2 is true, if it is true, then O1 and O2 hash code must be same. Object 1 and object 2. If two objects are exactly same, their hash codes must be same. But the reverse is not true. If object 1 and object 2 having the same hash code, they don't have to be equal. They don't have to be equal. So, but here we overrode this one and over an object O1 dot equals O2. If the two objects I gave with the same ID, it is returning true, but their hash code is returning different hash codes, then we are not following it. So what we need to do, that is why blindly understand that every single time you override equals method, you override hash code too. Especially in your collections. That is how your JVM will understand if two objects are equal or not. We call the hash code method on the object to find out where it's actually not trying to find out if they are equal or not. Calling the hash code method to find out where should I keep this object, in what location do I keep it. Do I keep this guy at index 1? Do I keep this guy at index 10? To find that out, it actually calls the hash code. But if they happen to have multiple objects already there in that location, then it will compare with every single object. Hey, are you guys same? Are you guys same? Are you guys? Because hash set does not supposed to accept any duplicates. Did I confuse everybody? Or you're okay? I understand that you may have to watch this video at least a couple of times. Okay? Now let's look at it. So what do we do now? Now, your equals and hash code, whatever the fields that you have taken your equals for, you need to take the same field for your hash code. So let's override the hash code. This is the most popular interview questions. I know I said most popular. How many most populars you do it? Well, this is, you go for 10 interviews, probably 7 or 8 out of 10 times they ask you, hey, what are the two important methods that you may consider you'll have to override when you're using collections, equals and hash code. Okay, what's the difference? Why would I do both of them? Can you tell me a little more about it? Don't get surprised if a person having 10 or 15 years of experience may not be able to answer. Can you tell me how the under the hood works between equals and hash code? I'm not bragging or anything, just saying it's just, it's not easy. But if you go to these tech companies like Amazon and Facebook, they kind of they expect you to know these kind of low-level details. Okay, public int hash code, and then so I'll say this dot id dot actually this dot id, I'll do it. Sorry, it's actually cannot convert from int too long. I'm typecasting to int here. I'm just returning blindly ID itself. Okay? But if you, in your equality, if you are comparing social security numbers, social security number is a string, right? In that case, let's say if two students are same, if their first name is same, then what you do here is that, do a this dot name dot hash code. This is how you do it, meaning you are taking the hash code of the name string. Okay? Or if you say that if two students living in the same city are same, then you do this dot city dot hash code. Of course, here you will do this dot city dot equals student dot get city. I think you got what I'm saying here. Okay? So your hash code and equals must go hand in hand. Or I'll just make it tricky. If you don't know what to implement in hash code, just say return 1. I'll tell you what exactly happens. You just hash code, you just return hash code equal to 1. Now I'll tell you, see in this case, hash code is same, right? 1, 1, 1, 1, right? All the hash code is same. You know what happens here? I want to tell you something here. Now, hash set is again backed by array data structure here. Okay, or where is our array here? Okay, yep. So we have array data structure here, and now you got S1. S1 is 1, right? I mean, S1 hash code is S1 student 1 hash code is 1. So let's say index is 0. I'll use a different color. Okay, I'm sitting here with S1 here. Now, when you gave me student 2, first I need to find out where I need to put student 2, right? I'll say student 2, you gave me index 1. Okay, now, sorry, index 0. I mean, hash code 1, index 0, right? Now I will try to go and put it as 2. Oh, there is already an object here at index 0. There is already one out there here. Now let me compare with every single object there in this particular index. Now I will compare S1 and S2. S1 dot equals S2. Because they happen to have the same hash code, it doesn't mean the objects are equal. What does the rule say? If the two objects are equal, then the hash code must be equal. But if two objects having the same hash code, they don't have to be equal. So that's why S2 also goes into the same index. Now, S3. Oh, S3, you also have the same hash code? Sure. What is your index? Oh, index is 0. Again, you are also same. Then I will call with S1 dot equals S3, S2 dot equals S3. Okay. False, false. Okay. So it's a different object. I'll put it S3 here. Now, S4 here, you also have the same hash code, buddy. Okay, what's your index? 0. Okay. There are already 3 people out there in the same index. S1, S2, S3. Now I will compare with the S4. S4 dot equals S1. Oh, it returns true. Oh, that means you guys are same. Then I will not add S4 here. So S4 will not be added. That is why in your results now you will see that the duplicate Venkat, this guy is gone here. Because they have the same ID. Right? So you can, one of the lamest way of implementing hash code is just return a standard number, but that is the most notorious approach. Do not take it. Okay, well, your code works. Your functionality wise, your code works, but what are you doing here? You are dumping, let's say, I will do like a 10,000 students here, right? All the 10,000 students will be added into one index. So all the objects I'm storing into one index. I'm not actually distributing the load across all the indexes. So when 10,001 object comes in, then with the same hash code, then there are 10,000 objects at index 0. So I'll have to compare every single object, 10,000 objects at index 0. So it is a performance issue, right? That is why you want to distribute all of them. So go ahead and change your hash code to your just student ID. Okay? Just return your student ID, this .id. But this is a long, but it is expecting only int, right? Now you typecast to this guy. This is called typecasting, meaning I'm reducing the value. Int is a small jar, but you are actually pouring from a very big jar. Even though you have a small content, you are pouring from a very big jar into a small jar. You can do it, right? So at that time, you will use this typecast. So of the same types, but you're lowering it down. Okay, anyways. So what do we do now? Now let's take a look at it here. So your hash codes are now based on the IDs. Now this guy has hash code 1. Okay, now let's see what happens. Now let's see what happens. I'll use a different color now. Now, when S1 comes into picture, hey, what's your hash code? Yeah, hash code is 1, my index is 0. Okay, I'll put S1 here, no problem. Now S2, hey, what's your hash code? Hash code is 2. What's your index? Well, let's assume from that complex algorithm, there are a lot of complex algorithms, okay, which I'm also not too good at, but we don't have to know. So, okay, what's your index here, buddy? Okay, index is 1. Okay, let me put S2 here. Okay, index 1. Now, hey, what's your hash code? 3. Okay, what's your index? Okay, index 2. Then S3 goes here. Now S4. Hey, what's your hash code is 1. Okay, index 0. Hey, there is already S1 sitting out there. Now let me compare with S1. I'm not comparing with S2 and S3. I'm only comparing with only S1. That's the beauty here. That's the performance. So if I have 10,000 objects, if I wrote my hash code implementation properly, I'm distributing these objects in this array. So 100 objects go here, 100 objects go here, 100 objects go here, 100 objects go here. What's the advantage? The performance. I don't have to compare with every single object across the set. I only have to worry about comparing the objects that are sitting, that are having the conflicting hash codes, meaning the same hash codes. Ooh, that's way, way, way too much for one day. So that is why now you saw it. Your duplicate is gone. Because it did not even compare, it did not even come to equals. The first thing is it will call the hash code, because if hash code are different, then I don't have to compare equals, right? If hash code are different, and then from hash code I'll come to the index. Okay, that index happens to be here. Well, there is nobody here, so I'll put S1 here, I'll put S2 here, S3 here, S4 here. The reason is they're all having different hash codes. That is what the default implementation, you will get it from java.language object. But you override and provide the proper hash code, and your hash code and equals have to be always in sync. If the two objects having the same hash code, they don't have to be equal. But if the two objects are equal, their hash code must be same. And also, this hash code must always when I call hash code two times on the same object, it should give me the same. So there are some rules out there. Okay, that's about, it's a long story, but it's about equals and hash code. This is how your hash set knows that whether two objects are same or not. But under the hood, it's actually an array data structure, but it will spread the objects across. It doesn't maintain any index or anything. That is why there is no such thing like in set. There is no such thing like, can you please put me in index 0? There is no method like that. It's because under the hood, this is what is happening. Okay, any questions? I know I've taken a little over time, but does it make sense? You have a lot of guts. You said that makes sense, and in 1 hour, so you understood really, huh? Very good. I'm proud of you guys. You may want to watch this video at least one more time, or maybe 2 more times. Then probably you'll understand. But these are the concepts that everybody wants to ask in interviews, especially these big companies, big tech companies. And I'll not be surprised even if your guy who is interviewing doesn't know to this level of details. I'll not be surprised, because we don't have to know under the hood. I'm just saying it out of my interest. So, okay. But this is exactly what happens. But once you understand this, you will feel more better. You can solve the problems with more understanding. You can copy paste any day, but that's not what we are looking for, right? Concepts based learning. Fantastic. Have a good night, everybody. And then I'll email you about the next class, whether we are having tomorrow or not. Okay? Thank you so much. Bye
Thanks,
now.
Venkat. Bye.
Yep.